Significant figures. Significant figures are the numbers of digits in a value, often a measurement, that contribute to a degree of accuracy of the value. The larger the number of significant figures in a measurement, the higher the accuracy of the measurement. If a number is given, we can determine the number of significant figures using four rules. We will study the four rules of determining significant figures. The first rule says that all non-zero digits are significant. For example, if we have the volume of an object to be 178.43 centimeter cube, there are five significant figures which are 1, 7, 8, 4 and 3. In this number, no number is a zero number, meaning that all numbers are a non-zero number, so all the digits are going to be significant. So we have five significant figures. So this is your first rule: all non-zero digits are significant. The second rule says that all zeros between two non-zero digits are significant. For example, if we have mass of the object m is equal to 168.02 grams, it has five significant figures. How? 1, 6, 5 and 2 are non-zeros. That is why from rule number 1 I can tell that 1, 2, 3, 4, four significant figures I already have from rule number 1. What does your rule number 2 says? If we have a 0 coming in between two non-zero number, then even this will be significant. So how many significant figures we will be having in this? We will be having five significant figures. Rule number 3: if the number is less than 1, the 0 or zeros on the right side of the decimal point and to the left of the first non-zero digits are not significant. For an example, if we have 0.001405, the underlined zeros are not significant. Why they are not significant? Because these zeros are coming left of your non-zero number and also left of your decimal point. Right? So how many significant figures will this number have? It will have 1, 4 and 5 are three significant figures from rule number 1, because all non-zero digits are significant. Next, from rule number 2, what you can say? The rule number 2 says that all zeros in between two non-zero numbers are significant. So this is a zero coming in between two non-zero numbers. So in this whole number, how many significant figures are there? 1, 2, 3, 4. Four significant figures will be there for this number. Rule number 4: zeros on the right side of the last non-zero numbers are significant. But there is an exception for this. The number must be written with a decimal point. Let us take an example for this. If we have 1.500 or 0.01500, both will be having the same significant figures, that is 4. Okay, why here these two zeros are significant? Because these two zeros are coming on the right side of a non-zero number. So 1, 2, 3, 4, all the digits are going to be significant in this case. In this case, 1, 2, 3, 4, all these four are going to be significant because 1 and 5 are a non-zero number and these two zeros are coming on the right side of your non-zero number. That is what your rule number 3 says, right? And also the number coming to your left, it is not significant, right? Or sorry, the zeros coming to your left are not significant. So this will be also having only four significant figures. Now if I take 1500, this will be having only two significant figures, that is only 1 and 5 here, because even though these zeros are coming on the right side, but they are on the left side of the decimal point, right? We can consider the decimal point here. If we write 1500, that is why in this case for 1500 or 25 2500, anything if you take, the significant figures is going to be equal to only. So we have basically four rules for determining a significant figure. Okay, first, what does it say? All non-zero are significant. Okay, all the non-zero number, any non-zero, 1, 3, 5, anything. If the number is a non-zero, then it is what? Then it is significant. This is what your rule number 1 says. What does your rule number 2 says? Rule number 2 says that if two zeros are coming in between two non-zero numbers, then also it is significant. The third rule says that if the number is less than 1, or you can simply say that if zeros are coming to your right, then it is significant. If they are coming towards your left of a non-zero number, here we have non-zero number. If zeros are coming to your right of a non-zero number, then they are significant. If they are coming to your left, then they are non-significant. Rule number 4 says that if the zeros on the right hand side of a non-zero number are significant, okay, if they are coming after a decimal point, okay, so 1.500, this will be having four significant figures as we discussed, but 1500, that is 1500, will have only two significant figures, because here, even though the zeros are coming to your right hand side, they are on the left when compared to your decimal point. So if you know these four rules, we can solve any problems based on significant figures. So let us take few problems on significant figures. So how many significant figures are there in the following numbers? So the first is A, 98.7 plus or minus 0.2. This is the first question. Now, whenever you are getting plus or minus, whatever the number is there, this number you can neglect. So this, what you will be doing? You will be neglecting. Okay. Now, what is the number left here? It is 98.7. From rule number 1, what does rule number 1 says? All the non-zero digits are significant, right? So here 9, 8 and 7 all are non-zeros. So I can tell three significant figures for option A. That is the sub question A. Similarly, if I talk about sub question B, so here I have 8.783 multiplied by 10 to the power 9, meaning that 10 followed by how many zeros? 9 zeros. Right. Now, whether we have 10 to the power 9, 10, 11, 12, it does not matter. Why it does not matter? What does our rule says from here? If any zeros are coming towards your right, but they are a whole number, meaning that there is a decimal point towards the right of the zeros, then what should we consider? Should we consider these zeros are as significant? No. So this will not be significant, only this we have to consider. So in this case, how many non-zero numbers are there? 1, 2, 3 and 4. So I can tell four significant figures for B. Similarly, I will be taking for your C. For C, 10 to the power minus 6, or whether it is plus 6 or minus 6, it does not matter, right? This we need not consider. Only these digits we have to consider. So 1, 2 and 3. So we have three significant figures for option C. Option D, how many significant figures will be having? We know that if the zeros are coming towards your left, right? Which rule is this? The third rule, what does it say? If they are coming towards your left, then it is not significant. So these zeros are not significant. So how many numbers are there? The non-zero numbers, only 3 and 5. So I can tell two significant figures. Similarly, for your E, 1, 0 and 2. 1 and 2 are non-zero numbers, and 0 is coming in between two non-zero numbers. So this, from rule number 2, I can say that here all the three are going to be significant figures. So option E is 3. Next, for your F, it is similar to your E. How many significant figures? Four significant figures. For your G, only one significant figure, because if 0 is coming towards your left of a non-zero number, then it is not significant. So you need not consider these zeros.